Alright guys, so we're going to start a video on the air handler PMs. What we're really focused on here, this is the blower cavity. The blower itself, we really need to pay attention to the alignment on it. This particular one, it intakes through here and pressurizes this whole cavity, which then forces air down into the duct. And so the rotation on this is going to be where the air catches and then flaps out. So this should be rotating in at the moment a counterclockwise orientation. It'd be clockwise the other way if I was standing over there. As you can, you may not be able to see it, but this blower is very dirty. It's got a lot of buildup on it. I would suggest doing a good cleaning on it. Now this one's a fairly easy clean because of the design. You could get a good stiff bristle brush, run through that, and it wouldn't take much to clean this one. Unlike many of the other blowers we run across, they tend to be a lot more challenging in trying to clean them. And those we may have to open up a service call. This is one we could easily clean on like an annual PM is when I would suggest doing it. It wouldn't take that long, just a quick brush over it, it'd be done. Again, some of the other more traditional blower styles, they're a lot more work intensive, and so those we would recommend an actual service call to take care of. The next thing we're going to come over to is the actual bearings. So one of the things we're looking to do is just listen for the bearings. You want to pull your belts off, and when you pull the belts, you're going to be grabbing that bearing and that sheave and pulling it side to side and up and down to see what kind of play you can get out of that bearing. And so if you don't get any play at all out of it, you know, you're doing really well. But if you start getting to where you can hear it, you start seeing the play visually whenever you can move it, that's an obvious immediate indicator that bearing is in failure. The other side of that is, you know, being able to do an SKF reading. Now, a setup like this, an SKF reading would be fairly dangerous. I don't know that I'd recommend that, just because how close we are in proximity to all the mechanical operation. This is not a safe environment to take an SKF. You can on the motor, but I would not recommend it on that bearing there. But nonetheless, it is important to check. It's important to pull the belts and look at that. Another big key factor is we need to be checking the actual belt alignment, making sure that the belt, the sheaves are properly aligned, the motor is properly aligned. The best way to do that is by the laser alignment if it's available. If we don't have it available, you can do a flat bar or a straight bar. I would recommend having something like that on you just for that as a backup. That is my go-to if I don't have the laser alignment with me. So the alignment itself is very critical to belt health and belt life. Most of our large PMs, we do include alignments in the PM, so if the alignment is included, we need to do it while we're there on site. When you're doing that inspection, go ahead, take care of the alignment and get it out of the way. We need to pay very close attention to the belts themselves. You know, the belt tension is good. You know, we need to have your belt tension, like this here, not that you can really see it much, but this one I would consider has really good tension. It's on the tighter side. It could probably be a little bit looser and it wouldn't hurt, but it's not too tight. It's not putting too much stress on the belt. And you should be able to get good long life out of this. You're also going to check and see if you can see any kind of cracking or any kind of major wear along the belt edge. Check that belt all the way around. If you start to see a lot of fraying on the edges of the belt, that could be an indicator that the belt's getting old. It could be getting stretched. One of the things I'm going to warn you about is just because the belt is loose doesn't mean that the tension is actually the problem. The problem could be that the belt has gotten stretched itself, making it have a loose appearance, where if you come back and put fresh belts on, you know, the tension may be perfect on point. So that's one of the things we need to look for, pay attention to whenever we are doing PMs, is that we aren't just tightening things, or say we go replace a set of belts and the new set is extremely tight on those sheaves, well, we need to adjust that tension, because if we don't, we're going to do a couple of things. We're going to end up killing the motor bearings first of all. What you end up doing is when that belt tension is over tight, both the blower bearing and the motor bearing on the drive bearings, which is this side, end up having extra stress put on them and pull against them on top of the normal mechanical wear that we have. And so that ends up causing the bearings to have extra stress and pressure on one particular side, which builds additional heat and inevitably wears them down. That's one of the things that's critical, is the belts they should not be tight to the point where they're actually pulling on the equipment. They should be tight enough to where they make solid contact without putting too much pressure on the actual bearings. That is the true purpose of aligning them the way we do and setting the tension. So again, you put new belts on, the belts are tight, they need to be adjusted so that you don't end up killing those bearings inside of that motor. If you are able to take SKF readings, you want to make sure that you're within the company guidelines as to that. I will put those on the screen so that you can know and see exactly what we try to stick to for motors and bearings on what we recommend as tolerances. So we'll get all that in there as well. The motor itself, we need to be documenting the motor tag. We need to check the pecker head always, make sure the electrical connections are good, make sure they've got more than just wire nuts in here. We either want a Polaris connection, or we have ran into them where it's a lug connection, but it has a wire nut cap on it to protect it. So just pay attention to which one you have. The company preference is Polaris. If they have the other lug design, it is acceptable, but as long as it's not just a regular wire nut. A regular wire nut will generate a lot of additional heat and poor connection, which creates a lot of stress, especially if you're on a VFD, which the majority of our equipment nowadays are. The connection that is created in the wire nut versus a Polaris is a lot poorer quality, and so that the pulsing of the VFD ends up actually creating a lot of extra harmonics inside of the motor, which wears the bearings, wears the motor, wears it all out even more. Another thing we got to really pay attention to is the motor sheaves. We should be documenting all the sheave sizes. So again, you're going to get your motor tag and you're going to get your sheave sizes. They'd be either on the front or back if you can actually get to the actual numbers on the sheave. If you can't, that's not a problem. You just need to have a measuring tape on you. And what's critical is we get the shaft size, and most of them are measured to within 1/16 of an inch. So you get the shaft size, and you get the overall sheave diameter. Okay, so if it's a 6-inch diameter, whatever the diameter of the whole thing is. The next thing we need to know is the number of grooves. So this particular one is a 3 groove because it has 3 belts. We also need to notate what size the belts are. These are B belts, whether it's a B, A, or C. Those are the 3 that we run into in our end of the industry. And then the final thing we need to know is it on a hub or is it bored? Okay, so a hub means that it has a literal hub that the sheave mounts to and uses tension to pull up on and hold itself in place. A bored sheave has no hub. It's literally the sheave mounts directly to the shaft and tightens down typically with some sort of Allen key. So those are your 2 most common types that we run into and that you'll face. And we need to document which kind we have. Alright, the final thing we want to cover on the blower section, just make sure we grease. So with what we use right now, our current standard is all bearings outside of a cooling tower fan itself. We're using the blue mobile grease. We do carry it at the shop. That should be a stock item on your vehicle. So every inspection that we do, every inspection you should be doing at least 2 if not 3 pumps per bearing on every single bearing on that piece of equipment. With that being said, there is another bearing on one like this back here that we have to get to. So back in here you've got your rear bearing. Now this one does appear to have a line that it goes through, but what I want to warn you of is you got to be very careful when you start dealing with lines like these. So here's a trick that I apply. If I'm greasing it straight to the bearing, I do 3 squirts myself. Okay. If I've got a line like this, I will do 5 to 6 squirts, and here's why. What'll happen is this line will be full of a bunch of air gap, because this bearing over time as it runs, it will literally pull the grease, siphon it back into the bearing, and so you'll get these whole sections of gap. So if you only give it 2 or 3 pumps, you'll just end up refilling the line, and you won't actually get any fresh grease to the bearing itself. So if I'm doing a line like this, especially a longer line like this one, I'll do at least 6 pumps. That way I know I'm refilling the line, and I'm also getting fresh grease to the bearing. Okay, just a trick that I do, something I learned the hard way over time. We can't forget about the backside bearing either. So again, this is not a bearing that it would probably be safe taking, just because of how close you are in the airstream. There's a lot of air that moves right through here, so I don't know that I would take an SKF reading, but we still, whenever we're here, we need to be doing our side to side, up down checks, make sure we get any kind of play. You know, we can document all of that and see if there's anything we need to do. Now, moving on, you can see a temperature sensor here. So for something like this, we just need to make sure that these sensing wires, which this one has actually been decommissioned because nothing's wired into it. Anyway, you just need to be mindful of sensors in here. This is another sensor that the automation is going to be using. This is an averaging sensor that runs over a span of a space, and it's using this whole line here to get an average temperature over this section of air. So looks like it may have come set up to use this sensor, and the automation retrofit, they changed over to a different type. We want to be mindful of the drain pan in here. You can see this pan is very, very dirty. It's got a lot of goop on it. During any kind of annual inspection, we should be cleaning all of this. We should be, if we don't do a hose down, well, on some accounts we do, then we would come in here with just a shop vac or something and try to clean this up, clean all this down here up, get all this trash out of the pan as best we can. You can see here, this has got also a lot of gunk in it. All that should be cleaned out during the inspections, and then especially if it's a more severe pan, what we can do is just leave pan tabs scattered in the pan somewhere, so that we can cover a larger surface area and try to keep some of this eaten up, so it's not constantly building up in the system. We also have to be taking care of the drain system. Okay, it is very critical that we take care of the condensate drain. I can't say that enough. All right, so condensate drain here, again, very critical that we take care of this. Whether we run something down in there to clear it out, flush some water through it. This runs through to a floor drain over there. One thing that I sometimes do is I'll take a rag or something, stuff in right here. I'll just put a little shop vac on the other end and suck everything through. There's any number of ways of doing it. It's whatever you have available at the time, as long as you just get it done and get it done correctly. These condensate drains are extremely important. I'm not concerned about whether the contract says do a thing about the condensate or not. We're going to take care of it, period, because it's part of a good inspection. The other thing is the chill water piping itself. So big thing we're really looking for is that we have good insulation. All the insulation is healthy. It's not all rotting off or messed up. If you did come in here and see a big section of insulation missing or anything like that, then we would want to go in and recommend, repairing that insulation. If you see right here, you'll see a little valve down here. This is a flow regulating valve. This is not something you want to mess with or touch or do anything with. This is for the sole purpose of flow balancing this coil so that we have a set water flow through it. If you do have to isolate the coil, always use the isolation valves that are specifically designed for that. Some of the other things we can look for to see if they're there is if we have temperature gauges. We want to check that they're accurate, see how well they're doing. If they're clearly off or if it's very obvious that they're out of calibration, we recommend replacing them. Get whatever information you can off of these, and if they're in a well or not. The majority of them will be, but even take a picture of it so we can send it in so that whenever the sales team goes to put their repair proposal together, they kind of have an idea of what they're looking for. Same thing on the pressure gauges. If the pressure gauges just look completely off, then again, we want to recommend replacement of it. And we also have to pay attention. This one has an isolation ball valve on it, but they may not always have that. So if they don't, again, that's just another thing we need to just be mindful of. When you're recommending repairs, when you're recommending items, you have to think about those things from a perspective of, okay, if I was to come do this now, what would I need? And then look at what's available and to see what other information you're going to have, because that's the information that we have to provide so that the sales team and everyone else can do their job properly. Otherwise, all we're having to do is guess by what limited information is provided. So, pressure gauges, make sure everything's good insulation, nothing's leaking. You can come in here on the back side of this one, you can see the back of the evaporator. So it's important to check that, make sure it looks clean. Again, the condensate drain, you can see the back side of it here. This will be another place to put pan tabs if you can get to them. And then you've also got a hot water coil on this one. All the same rules apply on the hot water, short of the fact that the insulation is going to be a little less critical because we're not so much sweating. The insulation that is on here is more so that it can hold the heat, so it's not having to put so much heat back in at the boiler. But having a little bit of section here that is uncovered is not that critical. We're not losing that much heat through these little sections. So I wouldn't be worried about trying to recommend insulation here as much as I would if this was chill water, because chill water obviously is going to be sweating. So that's what we got to contain there. Again, you can see the backside of the hot water coil here. There is a condensate hooked up for the hot water, but it is not going to be used. That is for a different application, but they are required to hook it up by code regardless. In case the hot water coil springs a leak or something, it's got somewhere it can drain the water to. Then we come to the filters. We need to know how many filters we have, what the sizes are. These particular ones are a little dirty, but they're not extreme. They still got some life left in them. So it's very important that we document the filter size and that we are checking them to make sure they're clean. If they need changing, obviously recommend a change, or if that's included in that service, then obviously change the filter. But at bare minimum, all of that should be documented. Any kind of information that is set standard for this equipment that's going to be here, we need to document. Okay, filter sizes, the motor, if we can, the sheaves themselves, the sizes of them. If you can find it, the bearing numbers or sizes for the blower. Any kind of information we can get and put under that piece of equipment so that we have it no matter what, the better off we're going to be down the road, and the better our process is going to be as we continue to move forward as a company. Okay, so what you're looking at is the chill water actuator. This is an item that is part of the air handler that we got to pay attention to. This particular one is going to be controlled by 0 to 10 volts DC, but it will also have a 24 volt AC power supply to it. So with an actuator like this, we really need to make sure that the shaft bolts are good and tight. It's got a clutch on it we can operate to make sure that everything is moving freely, and then we can also unwire the 24 volts, which is typically the red wire, from it, and power cycle the valve, and it should go into a calibration after doing so. So that's just another item that we need to check and make sure it's working properly, everything's good and tight with, it's not showing any obvious signs of a problem. There are other styles, but the 0 to 10 for chill water is the most common you're going to run into, and you're going to have to worry about. So that's just another piece of the puzzle we got to look at. And then we come over here, and we've got a static safety. So this one might be return static, or the filter static, I should say. So this is just another safety switch we got to pay attention to. Make sure the terminals are tight, the wires are good, all the connections are good. This one's missing its cover plate, but that's okay. We need to make sure that just this whole assembly is good. There should be another one on the positive side of the system, on the supply, for the high static safety. So we got to pay attention to that one as well. Make sure the wires are tight. Make sure it's not tripping out. Again, this is all just part of the safeties that are built into the system. The automation and the fan control, whether it's VFD or however they're controlling the fan, is going to be using these safeties to operate everything. So if one of them trips or is not functioning, then you could create a problem. Then we come over here to a economizer. I say economizer is more of a fresh air damper. So this is controlling your fresh air into the air handler. There's a direct fresh air dump straight into it. Now the system should always be set up to have a minimum of 10% fresh air. And so the big thing here is just making sure that your lugs are tight, it's tight on the shaft, everything's positioned, it's properly anchored. And then again, this is going to have a similar wiring to the chill water actuator, whereas if you should have a 24 volt power coming in. If you disconnect that power and reconnect it, it should cycle to calibrate. Another interesting thing about this particular design, not all will have, is it's got a directional switch right here. So if you ever wanted to test this to see if it was opening and closing properly, you could flip this little black dial here to change turning to the turn direction, whether it be reverse acting or direct acting. This refers to it as clockwise or counterclockwise. And it will actually, you can watch the actuator actuate at that point, and you can verify the gears. One of the big things that we've got to pay attention to with actuators is the gears do strip out. They're all plastic, and it may work for half an inch of travel, but then the rest of that it may start stripping. You'll hear the gears in there just jumping gears, and it'll get hung up in that position. It won't move past that no matter what you do to it, unless you manually turn it back to where there's a good, healthy gear tooth. So that's what we've got to pay attention to and be prepared for, and that's what we're looking for is, has the motor began to fail, and are the gears still in good condition? And the only real ways we have of checking that is to actually run the actuator and test it to see how it operates and what it's going to do. The very final piece that we have for our air handler is going to be our starting components. This one is VFD driven. It could be VFD, it could be a starter, regardless of how it's ran. We've got to go through this system every time, okay? This is part of your normal electrical checks. You got to pull all the panels off, shut this down, tighten all your lugs down in the main body, tighten your VFD lugs up here for the coming off of the drive. This does have a bypass. This whole bottom section here is the bypass. This whole top section is the actual drive piece. You're going to have all your control wires coming in on the side. Every bit of that has to be tightened. Every bit of that has to be checked. Look for any burnt wires or any scorched terminals, anything at all that's going to indicate there's a problem. It's better to catch it in the PM than let it turn into a service call later. So go through, hit all your terminals, tighten everything, make sure it's good and tight, and then just put it back together. You're going to go through this, and like I said, even if it's a starter inside of a starter panel, whatever, you're going to do the same thing there. With the starter, you're going to be going through the actual contacts and checking the contacts just like you would any other system, with a starter or a contactor. If it needs a contactor kit, or a contact kit, we need to recommend one. Or if it just needs to be replaced altogether, again, we need to recommend replacing it. So those are types of items that we got to keep up with on every inspection. Electrical checks should be every single inspection. An alignment, we can focus on more of the annuals, something like a blower or a drain pan cleaning. Again, we can focus on the annuals. But every single inspection, we should be going through all the electrical, all the controls. We should be, at minimum, just inspecting the drain system to make sure that it's still in good condition. You don't have to go through all the steps of necessarily clearing it unless it needs to. Again, if they got cleared on the annual, you show up on a quarterly and it's stopped up again, we got to clear it on a quarterly. Just go ahead and take care of it. It's not that much extra, and we don't mind as a company just going above and beyond for that customer so that they don't have problems with their equipment. Those are the basic fundamentals of doing your large air handler PMs for specifically a chill water coil system. This is the standard we need to be doing things by and what we've got to be paying attention to. I appreciate you guys. We will have more videos coming.